In the heart of East Africa, a monumental undertaking is reshaping the landscape and the future of an entire region. The Grand Ethiopian Renaissance Dam, or GERD, stands as Africa's largest hydroelectric project, a symbol of national ambition and a beacon for development. This colossal structure, rising on the Blue Nile, represents more than just a power plant. It embodies Ethiopia's long-held dream to harness its natural resources, generate crucial electricity, and drive economic transformation for millions. It's a testament to human ingenuity and an investment in a self-sufficient future, marking a pivotal moment in African infrastructure. The GERD is strategically positioned on the Blue Nile, approximately 15 kilometers from Ethiopia's border with Sudan. This river, originating from Lake Tana in the Ethiopian highlands, contributes the vast majority of the water that ultimately flows into the main Nile River. For centuries, this immense resource flowed largely unutilized by Ethiopia, while downstream nations have long relied on its bounty. The decision to build GERD was rooted in a critical need for energy and development within Ethiopia, a nation where a significant portion of its population still lacks access to reliable electricity. It was conceived as a path to industrialization and poverty alleviation. Ethiopia's ambition to utilize the Nile's waters dates back decades, with initial studies for a major dam on the Blue Nile conducted as early as the 1960s. However, political instability, lack of financial resources, and regional sensitivities consistently stalled these plans. The early 21st century brought renewed determination, culminating in the bold announcement of the GERD project in 2011. This time, the commitment was unwavering, driven by a national consensus to transform the country's economic prospects. It marked a definitive shift, prioritizing self-funded development over external dependencies, fostering national pride and collective ownership. The construction of GERD began with an unprecedented scale of earth-moving and site preparation. Thousands of workers and heavy machinery transformed the rugged terrain of the Blue Nile Gorge into a foundation capable of supporting Africa's largest dam. This initial phase involved diverting the river's flow, excavating massive quantities of rock and soil, and establishing the basic infrastructure needed for a project of this magnitude. Roads were built, power lines installed, and temporary housing erected, all in a challenging, remote environment. This systematic approach laid the groundwork for the structural marvel that would follow, showcasing meticulous planning. The GERD consists of two primary structures, the main dam and a saddle dam. The main dam, standing approximately 155 meters, 509 feet, high and stretching 1,780 meters, 5,840 feet, in length, forms the central barrier. Its construction primarily utilized roller-compacted concrete, or RCC, an innovative dam-building technique. RCC involves placing concrete in layers and compacting it with vibratory rollers, similar to how asphalt is laid. This method significantly speeds up construction, reduces costs, and results in a stronger, more durable structure, making it ideal for the GERD's immense scale and challenging location. Roller-compacted concrete is one of the key engineering innovations defining the GERD project. Unlike traditional poured concrete dams, RCC requires less cement, reducing heat generation during curing and minimizing the risk of cracking. Its dry, stiff consistency allows for rapid placement and compaction, leading to construction rates up to 10 times faster than conventional methods. This efficiency was crucial for a project of GERD's timeline and budget, allowing Ethiopian engineers and construction teams to overcome logistical hurdles and achieve impressive progress, cementing its status as a benchmark for modern dam construction globally. Complementing the main dam is a saddle dam, situated to the northeast, which closes off a lower section of the reservoir perimeter. This secondary dam, about 50 meters, 164 feet, high, is also constructed with roller-compacted concrete and ensures the integrity of the reservoir. The GERD also features two spillways, an uncontrolled main spillway and a controlled auxiliary spillway. These critical components are designed to safely release excess water from the reservoir, protecting the dam structure during periods of high rainfall and ensuring regulated flow downstream, a vital aspect of responsible water management and flood control in the region. The total estimated cost of the Grand Ethiopian Renaissance Dam project is approximately $5 billion US. What makes this figure particularly significant is how it was financed. almost entirely through domestic efforts. The Ethiopian government chose a self-financing model, relying on its national budget, public bonds, and contributions from its citizens, both at home and abroad. This approach underscored a powerful message of national sovereignty and self-determination, avoiding foreign debt for such a crucial national asset. It mobilized an entire nation behind a common vision, fostering a sense of collective ownership and immense pride in the undertaking. Breaking down the $5 billion investment reveals the sheer scale of expenditures required for such a mega-project. A significant portion covers the massive quantities of construction materials, cement, aggregates for concrete, steel, and specialized equipment. Labor costs for the tens of thousands of workers employed throughout the project lifecycle also account for a substantial sum. Furthermore, expenses include advanced engineering designs, consultancy fees, and the establishment of extensive on-site infrastructure. The investment also encompasses environmental and social impact mitigation measures, ensuring that the dam's benefits outweigh its potential disruptions, all contributing to this monumental financial commitment. Once fully operational, the GERD is projected to have a staggering installed power generation capacity of 6,450 megawatts (MW). This immense capacity will be produced by 16 Francis turbine units, housed within two powerhouses, one on each bank of the Blue Nile. This makes it by far the largest hydroelectric power plant in Africa, capable of generating enough electricity to meet the demands of Ethiopia's rapidly growing population and economy. It represents a monumental leap in energy security and a critical step towards industrialization, positioning Ethiopia as a regional power hub with significant export potential to neighboring countries. The process of filling the GERD's massive reservoir, with a capacity of 74 billion cubic meters of water, has been a meticulously planned and carefully managed undertaking. This multi-year process began in 2020, with subsequent filling phases completed during Ethiopia's rainy seasons. The impoundment of water is critical for testing the dam's structural integrity and commencing power generation. However, it is also the most contentious aspect of the project, as the rate and duration of filling directly impact downstream water availability, sparking intense diplomatic negotiations and requiring sophisticated hydrological monitoring and data sharing to ensure regional water security. Beyond electricity, the GERD is fundamentally reshaping infrastructure across Ethiopia and potentially the wider East African region. The sheer scale of construction necessitated the development of new roads, bridges, and communication networks to transport materials and personnel. The resulting energy surplus offers Ethiopia the opportunity to industrialize, expand irrigation for agriculture, and electrify remote areas. This infrastructural boom is not just about power, it's about connecting communities, facilitating trade, and laying the groundwork for sustainable economic growth that can lift millions out of poverty and integrate Ethiopia more deeply into the continental economy, forging new pathways for development. The construction and operation of GERD have ignited complex regional water politics, particularly with Egypt, which relies almost entirely on the Nile for its fresh water. Egypt historically claims specific water allocations based on colonial-era agreements, which Ethiopia was not party to. Their primary concern revolves around the potential reduction of water flow during the GERD's filling period and during prolonged droughts, fearing severe impacts on its agriculture, industry, and population. Securing mutually beneficial agreements on filling and operation remains a critical diplomatic challenge, highlighting the historical tensions over shared resources and national security. Sudan, another downstream nation, has a more nuanced position regarding GERD. While initially expressing concerns similar to Egypt's, Sudan also stands to benefit significantly from the dam. GERD can help regulate the Blue Nile's flow, reducing destructive annual floods that historically devastate Sudanese communities and farmlands. Furthermore, the dam's electricity could be a cheap and reliable power source for Sudan, potentially integrating into a regional energy grid. However, Sudan still seeks guarantees on the dam's safety and operational rules, emphasizing the need for robust data exchange and coordinated management to mitigate any potential adverse effects and maximize mutual benefits. For Ethiopia, the GERD is not merely an infrastructure project, it's a national development imperative. With over 60 million people lacking electricity, the dam offers a transformative solution to energy poverty, driving industrialization and creating jobs. It aims to unleash the country's agricultural potential through expanded irrigation, reducing reliance on rain-fed farming. Ethiopia views the GERD as an exercise of its sovereign right to utilize its natural resources for the welfare of its citizens, emphasizing that the dam is designed not to harm downstream nations, but to facilitate regional development and cooperation through responsible water management and shared power. The Grand Ethiopian Renaissance Dam highlights the delicate balance between national sovereignty and shared transboundary resources. While tensions persist, there is also immense potential for cooperation. A regional electricity grid, powered by GERD, could provide affordable and reliable energy to numerous East African countries, fostering economic integration. Joint management of the Nile's waters, based on principles of equitable and reasonable utilization, could transform the river from a source of contention into a catalyst for shared prosperity. The future of GERD hinges on continued dialogue, mutual understanding, and the establishment of robust, legally binding agreements among all riparian states, moving towards a win-win scenario. The Grand Ethiopian Renaissance Dam, a $5 billion engineering marvel, stands as a powerful symbol of Africa's capacity for self-reliance and progress. Its construction journey, marked by innovative techniques like roller-compacted concrete and financed by national resolve, has been a testament to human determination. As it moves towards full operation, GERD not only promises to revolutionize Ethiopia's energy landscape and infrastructure but also compels the region to rethink its approach to shared natural resources. The legacy of GERD will ultimately be defined by its ability to balance national development with regional harmony, setting a precedent for future transboundary projects across the continent. It represents a bold step forward for a continent charting its own course.